Welcome back. What we're looking at today is 2.6. We're taking and dealing with form follows function. So let's go ahead and jump on in. So for this first part, we're comparing linear and exponential models. So we want to compare different characteristics of each type of function by filling in the cells of each table as completely as possible. So for number 1, we have both equations. We have y equals 4 plus 3x, and we have y equals 4 times 3 to the power of x. So for this first one, the type of growth that this is linear. This is a linear growth because that is a linear equation. So this one over here would be exponential. One way to think about it is you have an exponent and your x is in the exponent, so it's exponential. For number 2, what type of sequence corresponds to each model? So remember, we talked about a linear function is the same thing, or is a overarching theme of a what kind of sequence? An arithmetic sequence. And exponential goes with geometric. All right, the next thing we want to do is make a table of values. So I'm going to take and use 0, 2, 3, 0, 1, 2, 3. So for x, if we plug in 0, 3 times 0 is 0, plus 4 is 4. Then we'll do 1. 3 times 1 is 3, plus 4 is 7. We'll do 2. 2 times 3 is 6, plus 4 is 10. And then 3. 3 times 3 is 9, plus 4 is 13. Now, over here on our exponential, we plug in a 0. Anything to the power of 0 is 1, so we have 4 times 1, which is 4. We do 1. 3 to the first power is 3. 3 times 4 is 12. Then we do 2. 3 to the second power is 9. 9 times 4 is 36. And then 3 to the third power is 27. 27 times 4 is 108. So what is our rate of change? What are we going up by each time in the arithmetic sequence? Going up by 3. We're adding it each time. What are we doing in the geometric? We're multiplying by 3. All right, for number 5, you guys are going to take and graph these. It's going to be easier for you to graph them. So remember, start with your y-intercept, then do your plus 3. You can use the points that we just found. That's going to make this nice and easy. We just did 4 points, so plot those 4 points. For your linear, you're going to have a line. For your geometric, you're going to have a curve. And then for number 6, you're going to find the y-intercept for each function. Hint, y-intercept is when x equals 0. So look at your table for help there, okay? All right, number 7, you're finding the y-intercepts once again. Y-intercept is when x equals 0. So plug in a 0 into each of those equations to see what your y value would be. All right, set. Efficiency with different forms of linear and exponential functions. For each exercise or problem below, use the given information to determine which of the forms would be the most efficient to use for what is needed. So we're looking at slope-intercept, point-slope, recursive when we're talking about a linear function. For an exponential, we have the choices between explicit and recursive. So for this first one here, for 9, Jasmine has been working to save money and wants to have an equation to model the amount of money in her bank account. She has been depositing $175 a month consistently. She doesn't remember how much money she deposited initially. However, on her last statement, she saw that her account has been open for 10 months and currently has $2,475 in it. Create an equation for Jasmine. So what do we have? Do we know her initial value? No, we don't. We don't know the initial value. So slope-intercept form probably would not be the best form because for that, we need to know the zero term. We need to know the intercept. So we don't want to use slope-intercept form. What about point-slope form? Can we use that one? Yeah, we can use point slope. We have a point, the 10 months and the 2,475, and we know how much it's going up each time, so we know the slope. So we can use point slope. So that's the form we choose. Now we want to write the equation. So y equals our slope times x minus our months, so our x1, which is 10, plus how much is in her account currently. And there's our equation. All right. For number 10, the table below shows the number of rectangles created every time there is a fold made through the center of a paper. Use this table for each question. Find the number of rectangles created with 5 folds. So how would we find this? Obviously, we have up to 4 folds, and we see 1 fold is 2 rectangles, 2 is 4, 3 is 8, 4 is 16. So how would we find 5? What equation should we use? Also, which function are we dealing with? Are we dealing with a exponential or a linear function? This would be exponential because we're going from 2 to 4, 4 to 8, 8 to 16. So we're doubling it every time. So if we're going up to the next number of folds, how would we find that? Think back. It'd be the recursive. So we'd have now equals previous times 2, because that's what our rate is. We're multiplying by 2 each time. Now for B, find the number of rectangles created with 14 folds. Are we going to use the recursive equation for that? No. We need to use the explicit because there's a break in the data. So we're not going from 4 to 5. We're going from 4 to 14. There's a big space in there. So our equation, we're going to have f of x equals, now our first term is 2, and then we're going to put in parentheses 2, because this is our multiplier, to the x minus 1. Now remember, you could have used 16 for this first 2 and done x minus 4. You could have done 8 and x minus 3, 4 and x minus 2. Any one of those would have worked. So this is how you're doing these problems. So based on the information given, you're going to determine, okay, would it be best to use point slope, slope intercept, or a recursive equation if I'm dealing with a linear model? And for a geometric, you're going to be looking at, okay, is it recursive? Am I looking for the next term, or am I looking for one that's further down the road? So that's what you're looking at there. All right. For each equation provided, state what information you see in the equation that will help you graph it, then graph it. Also use the equation to fill in any 4 coordinates on the table. We don't actually have a table. I don't know where it's talking about the table from. But so what we're looking at here is we have y equals 1/2 to the power of n times 8. So they write their explicit equations in a different order sometimes. So it's the same thing as saying y equals 8 times 1/2 to the n. Remember, multiplication is commutative. So from the equation, what do we know that's going to help us graph this? First off, we should know that 8 is the y-intercept. Anytime we have a number outside of the parentheses, that's going to be your y-intercept if it's being multiplied. If it's being added or subtracted, then it'll be moved based on that. But multiplying, it's going to look like this. So the number on the outside is always your y-intercept because the number in the parentheses is being taken to the power of 0, and the power of 0 makes everything 1. What else do we know? Well, we should know based on the rate that it's 1/2 each next value. So to graph this out, we're going to start with 8. Half of 8 is 4. Half of 4 is 2. Half of 2 is 1. Half of 1 is a half. Half of a half is a quarter. So we are getting closer and closer and closer to the x-axis. We will never actually cross it. We'll get infinitely close but never cross. So you guys can take and fill in that curve with a nice curved line there to show your graph. You'll do the same thing for 14, but 14 is a linear equation, so be careful with that one. All right, the last part is solving one-step equations with justifications. So we've got our different properties. We've got additive property. We've got multiplicative property. You are going to state what your justifications are. So for 15, 3x equals 15. So we're going to divide both sides by 3. So x equals 5. Our justification is division property. For number 16, we have x minus 10 equals 2. To get the 10 to the other side, we need to add it. So we have x equals 12. Justification is addition property. So that's what you guys are going to be doing on these. Yes, you need to give your justifications. It's good practice for when you get into proofs later on. All right, your keyword for this lesson is form, because we looked at different forms of equations. If you guys have any questions, feel free to ask. Once again, your keyword is forms, or form, not forms, form. All right, have a good day, guys.